Hey, good afternoon, everyone. Thank you for tuning into our weekly webinar. This week, we're going to focus on a little bit of speaking from Mike Hirschberg, Executive Director of Vertical Flight Society, followed by a few AFWERX employees speaking on the STTR process. Colonel Diller, over to you.
Great, thanks, Sterling. Yeah, we have a good group set up here today. The focus, exciting day first and foremost in the aerospace business. As everyone knows, expecting a space launch later on this afternoon around 4:30 Eastern time. So that's exciting opportunity to see some additional aerospace developments there. But for today, for our weekly webinar and ask us anything, ask Agility Prime anything, we have with us Mike Hirschberg, and then we're going to be talking through more details on the STTR process. So what is this? Why are we kind of combining these two topics together? And Mike will get into more details, but fundamentally, as we look to this future industry, we see that we are not necessarily going to have currently we don't have the engineers that we need in order to eventually launch this market and make sure that we have the support to create the types of development that we need. And so building that engineering workforce is critically important. And Mike will talk to some of the critical capabilities that are needed, the new approaches to thinking about engineering and aeronautics that are needed for electric vertical takeoff and landing, for the electric vertical takeoff and landing market. So those engineers are critical. Building that workforce of the future is critical. And so we're going to talk and kind of establish that foundation of why additional attention is needed as we start to move forward in what we are trying to do with Agility Prime, of fielding this commercial capability through the military program. So talking through that first, and then secondly, talking about some near-term opportunities that we hope to have out that will allow, as many of you know, again, the Agility Prime strategy from the outset has been one where we are not necessarily looking to dictate requirements. We're not looking to go create a military-specific program. And to that end, we're not paying for companies to go do specific research and development in particular areas to those requirements. And so the alternative to that is our funding with Agility Prime is focused primarily on enabling flight tests to reduce technical risk. That's the use of test ranges of test assets that are out there, some of the DoD test expertise, creating a path for airworthiness. So you've heard the approaches to that over the last few weeks of how we intend to do that. And then by doing that, eventually getting to data, that airworthiness then enables data generation and revenue generation. The data generation, hopefully to inform a commercial certification of these vehicles, and then revenue generation to reduce that regulatory financial risk associated with this eVTOL industry, and the ability for the Air Force to be an early adopter with fielding in 2023. And being able to do that through the products that you see at the agilityprime.com webpage, the solicitations for our areas of interest through that innovative capabilities opening, that it first starts the low-level entry potentially just onto our ranges, but eventually it creates an opportunity for a full procurement contract where the Air Force would be an early adopter. So that leaves a little bit of a question that was asked last week. And that question is, the funding for the current areas of interest are primarily focused towards that testing, towards that procurement, towards that early adoption. What we had suggested last week, there are other avenues to get some of the research and development funding. And so what we're going to talk about today, like I said at the beginning, is the need to develop that workforce. And then the next piece, we're going to talk to a process under the Small Business Administration for SBIRs and STTRs, and in particular, focusing on that STTR process today as an avenue for gaining funding for research and development, but also it creates this venue for collaboration between industry, the collaboration between academia and our research entities, also the potential of a collaboration between some of the larger companies through these STTR and SBIR processes. So that that is going to be the second part of our discussion today, is digging in. We've got some of the experts here who have really done some impressive work in restructuring a bit that program in a way that hopefully makes it a little bit more accessible to more players while keeping all the great things that have been innate in the program since it started. I think back as far back as 1982, where we're looking to those small businesses, the small ideas, but now finding ways of scaling them and becoming large, globally competitive companies in the near term. And specifically today, in a way that brings along universities, that leverages really some fantastic capabilities in the universities, that brings awareness to the university environment of the potential of this market and the need for these universities to begin developing that workforce, those engineers, as well as those operators. We'll have some discussions later on about the pilot and operator side of this. But today the focus will be on the engineering side, on the university side, and that fantastic opportunity for collaboration. So that's a bit of an overview for the discussion today in terms of where we hope to go in showing that interleaving, that triple helix between academia, industry, and university. I'm going to start with Mike Hirschberg, who is the Executive Director of the Vertical Flight Society. The Vertical Flight Society is tasked specifically with creating that academic touch points as well as those industry touch points to ensure that there's education in the industry associated with vertical flight. And they've done a fantastic job in both long-term, previously under the American Helicopter Society, and now transitioning a bit into this new age, as Mike has talked to, a revolution in vertical flight, and being able to bring together these different communities and begin to highlight what are the needs moving forward so that we can fully realize the benefits of this new technology and eventually get to this new marketplace. So with that overview, Mike, I'll hand it over to you, and thank you for joining us this afternoon.
All right, great. Thanks so much, Nate. Folks, as Colonel Diller said, you know, let's see if I get this work here. There we go. So we were founded as the American Helicopter Society, but we've really been interested in vertical flight since the beginning. So 75 years of working to advance vertical flight, and it's a professional society. It brings together industry, academia, and government. So we're a society of members, of individual members. So probably about a third of our members are government employees, and maybe a third are from universities, both students and educators, and maybe a third from industry. So we're all about increasing knowledge and understanding and advancing vertical flight. And you know, everybody can join us. You don't have to be an engineer or anything else to join. So vtol.org, and just a couple things over here to the right. I mean, here's an image of Joby's S4 eVTOL that they presented at one of our conferences in 2015. So this is a computational fluid dynamics showing the aerodynamics of the airflow around the propellers. So they've been with us since the beginning. We've been holding eVTOL workshops and information exchanges with inviting the public since 2014. We also have about $100,000 in student scholarships every year, trying to help encourage and support the best and brightest vertical flight grad students and undergraduate students around the world, so that we have the best and brightest in vertical flight. So I'm reviewing some of these slides that I had presented on May 1st in the panel that I chaired at Colonel Diller's invitation. So some of these charts are, well, actually all these charts are the same as I had presented before. or that some of the other panelists have presented. But now with this discussion of public-private partnership, industry, academia, government working together towards achieving these common goals. So you guys have probably seen the headlines in the last couple of months about all these people being hired by these eVTOL companies and some of the leaders from different helicopter companies or even from one eVTOL company to another. So there's a limited supply. There's a you know, it's kind of a zero-sum game of VTOL experts. The good news is for the last almost 40 years, the Army, NASA, and the Navy have been funding vertical lift research centers of excellence, and you know, about 36, about 36 grad students every year, masters and PhD students graduate. But that's barely enough for the helicopter industry today. So in fact, it's really not adequate because the Army, with the other services, has launched the Future Vertical Lift program, which, you know, now these companies that are winning the contracts are going to need to hire hundreds, and then for, you know, for the next phases, maybe thousands of engineers over the next decade to build these multiple simultaneous advanced rotorcraft programs. Now, they're not all vertical flight experts, or certainly software, all different kinds of engineers that don't necessarily have to have graduate degrees in vertical flight, but there is a limited supply. Just as a few specific examples, Scott Drennan, the head of the VP of Innovation at Bell, that was working on their eVTOL, and a long experience with the V-22 Osprey, was hired by Hyundai. Archer made news last week that they had formed this dream team of eVTOL experts from other different companies. So hiring people, lead engineers from Wisk and lead engineers from the Vahana program and Joby and Kitty Hawk. So basically the Airbus Vahana team was, Airbus Vahana program ended, and Archer hired almost the entire team. All of the subsystem leads now work for Archer. So this is not sustainable if we want to have a robust industry of eVTOL companies, as well as continue the DoD funded programs. It's a zero-sum game if we want to have, if the Air Force and industry wants to meet their goals and their timelines of developing these leap ahead capabilities in both commercial and military, both eVTOL and conventional fossil fuel burning turboshaft driven aircraft. Like I said, it's been fantastic that the Army, Navy, and NASA have been funding the Vlr Cos, but not at a high enough level. And the Air Force and the other services now have an opportunity, if they, if they want to have these programs be successful, all of the services and NASA and FAA or others have now the opportunity to enable this capability. We did some, and I have some charts here, but I mean, we in that presentation, in that panel discussion on May 5th, which I encourage you that are interested to go back and look at that, we came up with some different ways that with $20 to $50 million more per year, you could really see a really major impact on these future programs. So, if you consider hundreds, I mean, this is an example of Joby, a small group of Joby engineers with their prototype. They have something like 400 or more employees. Those engineers, if you look at each of these companies to be successful, they may need to go into production. Maybe they need 500 or, I don't know, 1,000 engineers each. So where are these engineers going to come from? Not all from the Vertical Lift Research Center of Excellence, but it's an opportunity where the government can help enable that. All right. So here are some different ideas on how to reach those goals. So we're really talking about funding graduate students. The universities are going to do research. Those will be helpful in solving problems, developing tools, but also in developing this talent pipeline. One Army engineer said, well, why should I fund the universities? Because I need aeroacoustics experts. Why should I fund the universities? How are they going to help future vertical lift, develop quieter aircraft? Well, because most of that stuff is going to be classified. Well, if they want future engineers working in that area, they need to fund research and help develop those engineers that know how to use these advanced tools and are developing advanced tools. There's probably only maybe a dozen or so aeroacoustics experts in the country. That are working in the rotorcraft companies, industry, academia, and government. And so noise is a critical factor in acceptability for eVTOL and is a critical strength. But, you can't just design something and, it's eVTOL, so it's going to be quiet. Well, it may be quiet, maybe not. One company tested their propellers, both ducted and unducted, and they figured that the ducts would be quieter. Well, they weren't. There are basic rules of thumb, but it also depends very much on the specifics of the design. So if the eVTOL community wants to have the experts in this, yes, they can outbid the government programs, the helicopter companies, to pay more and more for engineers for their companies, but in the end of the day, it's a zero-sum game. The Vlr Co pipeline, this talent pipeline, is very well developed, but it needs more throughput. It needs more flow, and one way to do that is with government funding. But here on the second major bullet here, this is also an opportunity where industry could invest some amount of money in a public-private partnership. That could be a risk reduction fund to help make sure that universities are funded, and maybe there's different types of regulations like an opportunity zone where maybe a company could invest in infrastructure, facilities, university research. Especially, if you're a high net worth individual and you've got a lot of money that's going into to meet your goals of developing this revolutionary electric aircraft, donate some money to a university to start some facilities, things like that. And because vertical lift research or vertical lift courses are really graduate programs, So, and that was really the impetus behind the foundation of the Vertical Lift Research Centers of Excellence in 1982. It's 3 centers now, 16 universities and in the U.S., plus 5 more around the world. But all the funding all the U.S. funding goes to U.S. centers or U.S. universities. Now, these are ones that have traditionally been more helicopter focused. There is a lot that can be learned and developed from more undergraduate programs, working with MAVs or UAVs, doing some more basic testing and things like that. But generally, it's more the advanced aerodynamics and advanced courses that get into developing autonomy, flight controls, using some of the more advanced CFD codes, the aeroacoustic codes, things like that. So to really get to the leads, the gurus for the different companies, they're really probably going to come out of either having a lot of experience in industry or coming from one of the Vlr Co research centers or universities. Now, there are 16 universities now. These are the ones that have existing programs, that have facilities. You need to have a bit of you need to have a center, you need to have a critical mass to do these types of research and develop graduate programs and have graduate degrees. But certainly more universities could be added if there's enough money going into both the universities and from public partnerships. scholarship. So there could certainly be more universities that could be added. And again, a lot of universities doing work on with drones and MAVs, and those are all good, and those will help undergraduate and graduate research. So they can certainly build centers. There are certainly more things that can be done. And there's different programs now. NASA has their AAM program to fund more, the national campaign to fund more things. There's also the university, ULI University, I can't remember what it is, but looking also at underdeveloped, let's see, sorry, looking at the chat here, looking at historically minority universities, things like that. So there's great partnerships, there's great talent. In fact, you know, I was talking with one of the university professors, and he says, you know, right now I'm maxed out. I don't have enough funding to even teach more students. I don't have more faculty. I don't have the ability to do more STTRs because we're maxed out. So it's a bit of a chicken and the egg, but I think that with some concerted effort, I think, and looking at the issue and how to resolve it, I think there's some real progress that could be made. So just a little bit of short summary of the Vlr Co program. So it's between $4.5 and $5 million a year. Army's most of it, about $3 million. Navy about $1 million, and NASA about $500,000. And the universities put in tons of money. It's significant cost share. It's a competitive effort every 5 years. The Army is the lead. They're going to be recompeting it next year. So it's an opportunity for the Air Force and other services, other organizations to join in and help fund these efforts. It's really a rigorous, it's really an opportunity for the government, industry to come in. Generally 40 or 50 representatives go to each of the, I think it's semi-annual reviews, look at what the research is, help guide it, come up with research topics. More and more of that is going into eVTOL now. And the funds, again, as I mentioned, primarily go into student support. But it adds a seed funding to attract other research, vertical lift-oriented research, and estimated, between 4 to 8 times more research comes into these centers because of the government funding. And it's really all matters, all technical issues related to vertical lift. So it's, they changed the name, I think 10 years ago, to Vertical Lift Research Centers of Excellence instead of Rotorcraft Centers of Excellence, recognizing that, there's a lot more than just rotorcraft when it comes to vertical lift. Another idea, there's a Vertical Lift Consortium. There's over 200, this is an industry association, but there's over 200 members now, including 18 academic and nonprofit organizations, including the Vertical Flight Society. There was previously something called the National Rotorcraft Technology Center, NRTC. This was folded under the VLC when it was started. Right now it's defunct, but it was a mechanism for industry and government to collaborate on pre-competitive research. So it's a 50-50 cost sharing between industry and government. So, this could be reinvented as a national VTOL technology center where companies, eVTOL, rotorcraft companies could collaborate with universities and government industry. And one thing that's really important is these longer term grant proposals. So the STTRs are good, but if the 6-month phase 1 isn't that helpful, because if you're looking to bring on to give a scholarship to a master's student or a PhD student, you really need to have longer term research grants. So if you get to phase 2, that's great, but phase 1s are a lot of work for 6 months effort. So they're not in themselves, they're great. More money, more research is always great, but they're not in themselves sufficient. So just as an example, as a 5-year, $5 million a year total, maybe half 50-50 industry and government, you could get more graduate students out. Maybe in the future, maybe it's industry takes on more cost sharing, obviously it's an opportunity for industry to fund more stuff and keep the rights, because there's different rights associated with that. So anyway, just kind of sum things up, lots of different opportunities for government industry collaboration with academia, STTRs, other, direct working with universities. They're all great opportunities, and I think they're really necessary. These types of partnerships are really necessary if we want to see both commercial and military use of eVTOLs reach the potential that we see. Otherwise, just like if there's a critical shortage in, batteries or, semiconductors or anything else, if there's not enough talented engineers, we're not going to reach the timeline and the goals of the cost, performance, schedule types of things that we all hope for. So with that, I'll end it here, and I'm looking forward to further discussion.
Great, thanks a lot for that, Mike. We've got several questions that are here that we'll get to. A couple of things I wanted to kind of talk through and ask you about a little bit more. Can you talk the distinction between the graduate research and the undergraduate research? I know that there are some of the institutions out there, Georgia Tech in particular, has started to look at this. Is there a case? Clearly a lot of the companies that are out there will be, looks like there's something spinning in the background there.
My solar powered electric helicopter. Oops.
All right. Supporting electric vertical flight as we speak. Certainly the companies are hiring graduate students, and that's where you kind of create your core. What do you see is the role in any of the funding that's out there for research for the undergraduate students?
So I think that pretty much every university, even ones that don't have engineering departments, are doing something with drones. So that's a really good hands-on thing that students can learn basics about, electric flight, vertical flight, things like that. And so, most schools have drone clubs. So it's a good way to get students interested and excited. There are universities can do design. There's design, build, fly competitions, types of things. We're actually going to be launching probably next year a VTOL design, build, fly, specifically for that purpose, to get more undergraduate and graduate students more hands-on experience in designing, building, and flying electric-powered, larger scale drones, but with the eye towards future eVTOL applications. I'm trying to remember the number now. Something like 4,000 aerospace engineers, just an example, looking at aerospace, graduate in the U.S. every year. It's, I think, about 1,500 master's students and about 400 PhDs. A total of about 2,000 graduate students in total. Not every person working on eVTOL needs to be have a graduate degree. Certainly a bachelor's degree in aerospace engineering or electrical engineering or computer science, all these really valuable skills, they're all necessary for developing eVTOL aircraft and understanding it for all the other subsystems and all the other things that need to be developed. So certainly undergraduate development and production is going to be critical as well. But for the really tough technical challenges, that's where we really see the Vlr Cos or other research programs that have these advanced aerodynamics and aeromechanics studies that being more useful.
Yeah, that's interesting too. from the perspective of the drones that you mentioned, what do you see as kind of the crossover between the two industries? Where there are things that you pick up and incorporate, and what are the things where there are key areas that need additional research as you're making the distinction? I guess are those universities that have been working in the drone space well postured, or would you recommend that they kind of focus, if they were to expand, where their focus is? What are the areas to expand?
Well, based on the based on the accredited engineering requirements for aerospace engineering, for instance, there's a necessary set of required courses and then electives. Generally, rotorcraft or vertical flight, aeromechanics, and things like that are in graduate programs. But certainly, eVTOL is a confluence of all these different adjacent technical and non-technical fields, right? So eVTOL is advances in manufacturing and composites and electronics and distributed propulsion. It's a whole new industry that's carved out of all these other industries. So I think that everything helps. People that have developed their own drones, or flying them, building them, understanding them, developing flight software, or doing anything with them. I mean, that's all going to be beneficial. It's a matter of what's the most beneficial. And so there are different projects and activities and electives, and some of the other associations like AFWERX has student design competitions. SAE has ground vehicle competitions, so there's different like electric vehicle type of competitions. So all these things are really helpful, because eVTOL is this, I'll say sort of this new industry carved out of all these other industries.
Do you see, and so to that end, from the work that has been done previously, do you see kind of a need to shift with the previous research that you've seen DoD fund? Should there be more specificity among the types of disciplines that are involved in this, in your opinion, in order to make sure you're capturing that correct breadth in the way that previous DoD funding has, or if not DoD funding, what are the avenues to identify where there are the biggest gaps? Is that industry that's providing that? Is it what's the best opportunity to find those gaps, and then to kind of recognize that signal to both industry, to academia, and then from a perspective of potentially providing additional funding, ideally through long-term and known quantities, but in lieu of that, some of the near-term STTR type approaches. What are your recommendations on that?
So your question is, who's looking?
Gaps. Yeah, what are the gaps? And how do you signal those gaps?
Yeah. So what research isn't being done or on a wide enough scale to enable a flying car future?
That's
the
right.
question. Yeah. Yeah. So that's a really good question, and maybe that's what we should be doing as a Vertical Flight Society is looking at that, because I don't know of anybody else that's really looking at that. So I apologize, I'm forgetting the name, but there's the ATEC, Aerospace Education nonprofit that looks at aerospace education. So maybe an engagement with them, we could look at some more of these gaps. One of the things, so we're working with 10 or 11 other associations and nonprofits. We coordinate on UAM related matters, so it's the UAM Coordinating Council. And one of the things we're doing is we're coming out, we've developed some white papers looking at things like workforce. So with that, we'll be publishing that, I think, in the coming weeks. And that's not just looking at engineering, that's looking at, instead of A and P mechanics, who's going to be working on these electrical systems. It's, the P and A and P isn't quite right. So I think through this coordinating council, which is trying to look at what are all the critical problems and how can we collectively as a community work to solve those. I think with working with Air Force, NASA, and other interested parties, we could probably look more holistically at the U.S. university network.
One other question too. Go ahead.
All right, I think you just assigned me work, right?
I'm sorry?
I think you just gave me a task, right?
Well, maybe gently. I mean, it's just to make sure that we do have the right process. If we're creating this relationship, making sure, right, it allows, I think, those limited resources to be directed in the right area. One other question too, along these lines, are there ways, maybe some more non-traditional approaches where a lot of short courses are available out there, maybe both at the university level, but even by some other research institutions? What role do kind of the non-traditional approaches to getting maybe these certificates, as opposed to having a graduate student research that you talk to? How do you see that playing?
Yeah, that's a good point. And then maybe we should have brought some of the other panelists from our discussion on May 1st, because they did mention that. So a few things. So we have an eVTOL short course. We've taught in person, and it's available online, so people can take a half day or a day long. We actually have several different ones, both in the fundamentals and in design. So we have that opportunity, and the instructor has also taught that at AFWERX courses, for instance, and they're starting to have some effect or impact broader. I mean, we've cycled through, I guess we've had it 4 or 5 times with about 75 students apiece. And I think we're starting to have some more impact. So you see things like, so all of our events, they're vertical flight focused. Other associations and other groups events, such as AFWERX, is more broadly looking at aerospace and aviation. They have AFWERX has their aviation conference in a couple weeks. It'll be all virtual and online. They have a number of different invited speakers, and there's different research papers. And you see more of those are focusing more on eVTOL. Now, I keep coming back to Acoustics just because it's very specialized. And as I said, there's only a handful of people in the country that have training in that area and know how to use the codes, or know. It's really a black art. So if you have if you're a professor or a researcher in jet noise and the impact on airports, it's not really all that analogous to, or it's not 100% applicable to spinning noise, or rotor acoustics or propeller acoustics, which are directional. It's all this unsteady noise. There's all these interactions. It's really the propeller wing and propeller to propeller interactions that are going to generate these different noise characteristics. So the rotorcraft industry, the vertical lift industry, have developed a lot of these tools, and it's a bit of a recognition from the broader or the greater aerospace community that eVTOL didn't just drop out of the sky a few weeks ago when Agility Prime had the great virtual launch, right? I mean, we've been developing these tools over 75 years. And the helicopter industry has been the rotorcraft industry for probably 30 years. And even if you look at some of the, what we call as the V-stall wheel, there's stuff that was going on in the 50s and 60s and 70s that were looking at jet thrust and, multiple propellers and things that weren't that much different. It was just shaft-driven thrusters. From an air mechanics perspective, is generally about kind of the same. So it's really, so there's a great basis from people that are not trained in the specifics of things that are spinning, external flow, rotational aerodynamics, and things like that. There's a great basis, but there's a lot of gotchas. There's a lot of specifics that even with supercomputers today, it's not an exact science. So it's designing the best you can based on the analysis tools and design tools. But at the end of the day, you have to have experimental testing to verify that this arrangement works not just in hover and not just in cruise, but in the really difficult part of transition, and then also in every other case of perturbations and different angles and approaches and banking and things like that. So it's a very nuanced and very difficult and challenge for it's easy to make something fly, but it's hard to make it a compelling product that meets all of the expectations from a future customer.
Do you see any major distinctions between kind of the traditional rotorcraft manufacturers and the relationship that they had with universities compared to what are we at now? This is also a means of getting an update to how many designs we're up to right now. The 275, 284, I don't know, 297.
284 was a couple of days ago. I'm not sure how many we've gotten on since then.
All right. It's still growing against some predictions.
We'll probably hit 300 in the next month or so. And honestly, it's a throughput issue. It's a capacity issue. We haven't had time to go back to all the people that announced and came out, hey, we're working on this through the Agility Prime launch. I'm so sorry for everybody that sent me a message on LinkedIn and Slack that I haven't gotten back to you. I'm doing my best, but it's really fantastic to see what electrical power distribution. So when the rotorcraft industry and the airplane industry has been working on fly-by-wire, which is a tremendous capability advancement from mechanical linkages. Well, now we have power-by-wire. So now you can put these propellers all over the aircraft in these crazy configurations, and it's really great to see this huge creative explosion. It throws out everything we've been doing for almost 100 years of airplane design with all these new capabilities, and that's why we call it the electric VTOL revolution. It's like the turbine engine revolution in the 60s and 70s to come up with all these designs that weren't, you could fly a tilt rotor with a piston engine. It was proven, but it wasn't until turbines were flight tested in the 70s that it was shown to really be a compelling capability. And that's what we're looking at now today, is these advances in technologies that make these configurations that were never practical before are now actually possible and hopefully compelling.
But I think it's great to see too, just the barrier to entry has reduced. There's a lot of things coming in across the chat talking about a lot of the non-traditional approaches to being able to learn in this space. The number of people who, and again, I know that this is one of the areas that the Vertical Flight Society tries to focus on is it's great the things that can be learned on YouTube and what's been done there, but it's also impressive some of the universities who are doing some of the distance learning courses that transition, some of the ability, of some of the tech schools even to create a cadre of people who are able to do kind of the manufacturing for the prototyping. So I think you combine all of that together, specific non-traditional ways of lowering the barriers to entry, in addition to just the technology in a lot of ways being less expensive. What do you see is some of the biggest risks though in that approach, and what can be done to mitigate those?
So it's absolutely a much lower barrier to entry than building a helicopter, right? Especially if high performance helicopter, you probably need a turbine engine, which are very expensive. I mean, generally, often $1 million for one turbine engine, or in that, a little bit less these days with some of the new turbines. But it's a definitely a lower barrier of entry to build something and fly something, but still, Mark Moore said during Agility Prime, he's what the numbers he gave was it's to actually have he said prototype. I'll say maybe a human carrying, vetted, tested, thoroughly tested prototype. So probably not not a subscale and not something that's you're just getting off the ground unmanned or for just initial testing, but something really would feel comfortable that's on the path towards a future vision. He said 100 to 150 million dollars to get to that prototype, and then 750 to $1 billion to get to a certified aircraft. So those barriers, and these are Uber's numbers, so. They've obviously seen a lot of different designs. I mean, they see even more than I do, than we do through our public eVTOL, the World eVTOL Aircraft Directory. Now, and I had, there was Kirsten Bartok-Tao last week was talking, well, I guess it was, anyway, was talking that it's probably a decade to get something to certification. Now, I don't know, maybe $1 billion in a decade, for a helicopter, okay, another aircraft, a larger aircraft, maybe okay. I mean, I really do think that with the, some of these innovative technologies, the Part 23, Amendment 64, the performance-based specs, the development of the standards that's been going on for some time. I really hope it's not $1 billion and a decade to get something certified, but it's not for the faint of heart. It's tough challenges. Developing a helicopter is really tough. Developing an airplane into certification is really tough. It's not easy, and people shouldn't dismiss the difficulty in that. I think that there are some opportunities for something that's maybe only in the hundreds of millions of dollars and maybe 5 years or something like that. But I mean, you look at Joby, they started in 2009, so they're already in 11 years since they began. They've gotten whatever it is, 700 some million dollars, so they're in that 750, almost at 750 to $1 billion to get the certification. Maybe they'll be able to do it cheaper. Some of that money is also to build out their production facilities and things like that. So, so it's definitely a lower barrier to entry to develop something, to design something, to build it, to fly it. But it's still going to be a lot of testing, tons of testing and redesign to make sure that it's safe. That you and I, our kids, our grandparents can fly in one of these aircraft with the reliability and safety record that's probably going to be like an airliner or close to it, to be able to have thousands or hundreds of thousands of flights a day. We can't have the kinds of well, we have to have almost unimaginable levels of safety compared to any kind of aircraft that's any other kind of aircraft compared to an airline, and really approaching that airline reliability.
Super. Well, I think we got through most of the questions there. There are several questions that have been asked about the STTR and SBIR approach. So I'm going to transition here in just a moment, but might give you kind of an opportunity for any last thoughts for the audience here.
Yeah, so thanks again, Colonel Diller and the team, the Agility Prime team. We're, as I said in my initial slide, right? So we've been here for 76 years now, coming up in, I guess, 77 years now, since we were founded in 1943. So we have hundreds of thousands of pages of documentation in our vertical flight library. We've got hundreds of hours of video, most of it available for free or free for members. So if you want access to tons of vertical flight research resources, join VFS. We've got corporate-wide memberships and access. I mean, our whole we're an educational nonprofit. Our whole reason to exist is to educate you guys. We have different webinars we've been doing now. We've got some short courses you can take to give a more of a fundamental appreciation of the fundamentals of vertical flight and eVTOL. We're a small, we have a small staff. I have 7 employees. We all work very hard for you guys to make vertical flight successful. We partner with the government, industry, academia. We're a global organization. At the end of the day, we do everything crowdsourced. It depends on people like you guys listening right now to join and help organize things, to move the conversation forward. This is, take a village. It's going to take, everybody working together to achieve these really, really hard goals of this vision of UAM, or advanced air mobility, that we think will be so revolutionary and transformative for society. So with that, I'll cede the floor then back to you, Colonel Diller, and standing by for any other questions as the conversation continues.
Super, thanks. Yeah, feel free to continue to send questions to Mike via the chat here, and he should be able to answer that. I want to transition over now to what are some opportunities for some of the research and development funding that's there. There are some questions in the chat about, what is the acquisition strategy? And so certainly we have a path for providing funding for procurement, for flight test, but there are opportunities. We've talked last week to some of the other government entities, and we're going to talk now to a group from the AFWERX. This is the new organization internal to the Air Force that has really done fantastic work to reach out across a broad set of industry players, some non-traditional industry players, and find good ways of getting them on government contracts and related to government contracts. So we have Zoe and Jared that are here. I think they'll be coming up on screen and on audio here to talk specifically about these opportunities through the Small Business Administration. And again, remember, this is funding opportunities with the STTRs, as they'll talk to, that specifically look to research organizations, both university as well as broader nonprofit research organizations. So a lot of folks have come up on chat describing some of the research entities that they have. And this may be a great opportunity for partnership between some of the small companies that are out there with some of the large companies as well. And then in particular with the research institutions, with the academic institutions, to start to build that workforce, to build some of the research and development that maybe we're not doing directly through the Agility Prime initiative, but being able to at least provide a venue of bringing these different players in. So with that, I'll hand it over to Jared and Zoe. Please continue to put your questions in the chat, and we'll have an opportunity for Jared and Zoe to answer those questions as we get through the slides that they have here. Now, one other follow-up, we will be posting these on the agilityprime.com webpage with both the audio, and then we'll get those slides posted as well, audio and video, and then the slides as well. So with that, over to Jared and Zoe. Thank you both for being here this afternoon.
Hey, Colonel Dilla, thanks so much for having us. Thank you again for the gracious introduction here. We're going to talk about the SBIR and STTR open topics specifically. These are things that AFWERX and an organization called Air Force Ventures have been really kind of honchoing over the last couple of years in the SBIR's case, and in STTR's case, something that we're just getting started, just got off the ground late last year, to really capitalize on existing Air Force and DoD and U.S. government programs, and ultimately capitalize startups and help buy down some of the risk that is inherent in product development and commercialization and so on. So before we go too far, I want to make sure that we foot stomp that all of these things that we're going to talk about, the SBIR and STTR programs are separate and distinct, but they're very much related. And one of those ways that they're related is in the solicitation cycles that happen 3 times a year. The next solicitation will officially open on 25 of August. 25th of August there. There is an opportunity potentially for STTR to have an out of cycle here later this summer. So as those details are released, I'm sure Colonel Dillard and the team will pass that out. So there's opportunity potentially for the STTR program specifically to have an out of cycle round later this summer. But in lieu of that, the next official solicitation will be available on the 25th of August. So with that, we'll move on to the next slide here. I'm presenting this in tandem with Zoe Walters, another one of our team members. It's going to be helping me speak to some of the SBIR specific things, as well as take questions here at the end. So here up front, we want to make sure that, hey, why are we here? Why, as a program, why are we doing these open topics? And there's a lot of things that we could say, but in short, federal research and development dollars have gone down as a share of the larger R&D community, right? And you can see that in terms of GDP. You can see that in terms of constant FY18 dollars. But the point here is that the federal government was at for a time a very large and the principal player in the R&D community, and that is just simply not the case at this moment in time. It wasn't a complete corner turn, but it was something that happened over time. And so ultimately where we find ourselves now is that, hey, it's a different R&D environment, and we have to come at this from a bit more of a shared perspective. So these programs, SBIR and STTR, really come at the problem from a dual use perspective. That is to say that we want small businesses not only to sell to us as a government buyer, as an Air Force, but also we want them to be commercially successful as well. So we have an eye specifically towards dual use technologies as opposed to very specific kind of military or DoD specific tech. One of the biggest things here that we'll see is that we want to leverage private funds, which is a new concept for much of the government, and ultimately share the load in terms of investing into R&D, such as eVTOL and other complementary tech, so that at the end we can all get to where we need to go. So the next slide here. So traditionally, for those of you who may or may not be familiar, STTR and SBIR have been, first of all, they've been around for a long time. SBIR started in the early 80s, STTR started in the early 90s. And up till now, up till this open topic, they've been run very, very similarly from day one, right? Ultimately, the DoD and the Air Force, Department of the Air Force are a single player. These are federal government programs. And they would solicit topics or problem statements, if you will, from the R&D communities in the Air Force, for instance. And the picture I have right there in the center is of the Navy version earlier this year, and you can see they're fairly specific, right? Energy attenuating seat design, machine learning tools to optimize additive manufacturing processes. They're very specific problem sets, and so small businesses will be incumbent to go and find problems that they could potentially contribute to, and then go through the solicitation process, which could be over a year from solicitation to actual contract award, right? There's a lot of things in here that we thought we could improve on. Not only just that one-to-one pairing model. So when the companies integrate with these programs, they only interact with that one problem sponsor, right? That was it. And so we really accentuate the valley of death concept in terms of product development by only having a one-to-one matching pairing or a matching model. So you only have one government POC. We'll see some of these things that we're trying to contrast that with in the open topic. But another thing is that, because they were solicited with a BAA, that is a broad agency announcement, which is just simply a version of a contracting vehicle from the government. It only allowed an R&D to R&D transition, which is an odd transition in many cases, especially when you're looking, you from a small business perspective, are looking for buyers or looking for capital. And ultimately, right, it was a near total reliance on the government's processes in terms of contracting and solicitation, and ultimately the motivation in terms of program management and transition at the end of the process. Ultimately, one of the major value propositions for these programs is that as you go through phase 1 and phase 2 vacation for your business, that's the scope that's included. Basically, what is able to happen is that traditionally we, the government folks, have to insert competition into our procurement processes. We have to compete things. And so through these programs, we satisfy that competition up front and early and in the development process. And then when it comes to transitioning, you qualify for what we call a sole source justification, which allows any federal government, not just Air Force or not just Space Force or DoD, any federal government agency to procure your solutions or your tech directly from you, which is, it's a huge value proposition on the government side in the fact that we don't have to try to wrangle the process for 9 months to a year. We can just come straight to you and purchase your things. So as we move on from that traditional process up to this open topic, one, we maintain that sole source procurement. That was a big value statement, both for the small business and for government. But we did a lot of things differently. As you can see, we keep phase 1 and phase 2, but we change the intent much more from a government-driven model to a user or demand-driven model. So first of all, any eligible small business that wants to do business with the government can come to the front door of our process, right? They can come to a Small Business Innovative Research, the Sbir, or Sttr as well, and say, hey, we would like to do business with the government. Their proposal is not a 50-page technical paper. It's 15 slides and 5 pages. That goes through an evaluation process, and they are awarded a phase 1 contract for $50,000 over 3 months. What that allows them to do during that time is, one, continue development of what they're doing, for that they proposed, but almost more importantly is a customer and application discovery. As you, one, start from an adequate legal basis to have really substantive conversations with the government entities that would be interested in their technology or solutions, and take those interested parties, the multiple interested parties in many cases, and move to a phase 2 effort where they're developing a prototype for those new users. We can talk a lot about the durations and the dollar amounts and opportunities to commercialize, but the point here is that there's a funnel aspect to it, and this is a demand-driven model. So when you find those stakeholders are empowered to work with you, not only through kind of centralized processes that we make easy, but also it gives you ramp up in terms of capital that's available to you, not only in phase 1, right? I mean, that's only 3 months, but phase 2, as the dollar amounts grow to $750K and up, and ultimately to the StratFi and transition levels, which can be 60 million plus in terms of total effort value. And so ultimately, it just gives you an opportunity to not only find and leverage the demand signal for your technology or solution inside the federal government, but also to scale that into really substantive contracts and commercial opportunities as well. So in terms of the open topic, just to dial in on some of the more nuanced details. So going from a requirements-based process where we're reliant on government folks to ask all the right questions, to a demand-based model where you as small business folks can come to us and say, hey, we are interested in, or we have this kind of technology. Do you think it would work for us? Instead of a 6-month solicitation to award timeline, or much longer in some cases, we're averaging 30 days for phase 1 contracts from the end of solicitation to the contract in hand, which is a big deal. The technical requirements, as we mentioned, have moved to a 15 slide now, 5-page technical volume for your proposal, which is a big value opportunity that lowers some of that barrier to entry. And, you know, ultimately, again, as you kind of look down at the bottom, it goes from a government-driven model to a business-driven model. You know, we want not only to find those initial adopters, those early adopters of your technology, but as you go through the process, continue to communicate value, not only to that community, but to others as well, and continue to diversify your customer base, both within the DoD marketplace, in the commercial marketplace as well. We think about this, you know, in a dating analogy in many cases. You know, you may start looking out for, and you have lots of different prospects, but as you kind of get deeper and more invested in the relationship, the stakes go up. Whether that be just proposing, they're at step one, moving through from phase one, the cup of coffee, as we put it, going out for dinner in phase two, moving up to the strategic fund increase, that StratFi I mentioned previously, and up to a $30 million contract and a $60 million effort value. And ultimately, that helps bridge into a program of record that is sustainable with your Air Force organizations and stakeholders, right? Then those are unlimited in terms of funding, unlimited in terms of period performance as well. All right. So a couple of things we want to make sure we touch on. So again, SBIR and STTR are separate and distinct, but they're very similar in many ways. SBIR is principally concerned with the development of commercial products for the defense market. So that's a lot of the non-traditional folks who are obviously in the commercial market, but haven't really broke into the defense side of things and don't really know where to start when it comes to doing business with the government. For SBIR, we offer two front door options. One is the standard phase one, and another is a pilot program that we started that is a direct to phase two. So with phase one being a lot of customer discovery, some companies have already done that to a large degree, and they know who those stakeholders would be, and those stakeholders have already demonstrated interest. And for those folks, we have an opportunity to move directly to phase two and speed up the process just a little bit. For STTR, we're really looking at the commercialization of research specifically. We start with a phase one only. There's not a direct to phase two option. And for STTR, and we'll touch a bit on this a little later, there is a requirement for a research institution to be involved as well. And we'll talk more about the definitions and the regulations and that kind of thing as well here on following slides. So there's a lot of detail here on this notional program flow. Long story short is that you can see the phase one and phase two moving into the strategic funding increase along the top there. One important thing that people don't always realize is that you can actually transition between the SBIR and STTR processes. So you could do an STTR phase one, for instance, with a research institution, and move into an SBIR phase two later on, if you would like. So that it works both directions. And in both cases, you can transition to a phase three contract at any point in time in the process. Again, where we as AFWERX are not intermediating those contracts, and we're not limiting, you're not limited in terms of funding or period of performance as well. So in the case that you find a stakeholder in phase one, and they have, they have the pocketbook and they really are enthusiastic about your solution, they can move directly into a procurement contract with you up front. All right, so moving into kind of the eVTOL space a little bit more specifically, we wanted to highlight the STTR program, the Small Business Technology Transfer Program specifically. As you know, there's a lot of research institutions or research entities involved in this that many of you represent. And we want to make sure that we communicate effectively on how you all can take advantage of these programs to commercialize, not only in the defense market, but also in the commercial market as well. Ultimately, the program here, as you can see, is intended to commercialize dual use research, right? That's really what we're here to do. The biggest things that we provide are we're trying to provide expansive and meaningful engagement, both directions, right? Not only the small businesses, but also the government marketplace as well. Our government users are our customer base as well. And ultimately, we want to leverage this DoD funding source to buy down some of this technology risk and foster the commercial success of the small business when they're moving forward. You know, a quick note here is that these are not grants. Many times they're referred to as Sbir and Sttr grants, but these are actually government contracts. So we are not awarding to universities or research entities. These are contract awards to small businesses very specifically. Those small businesses can partner, as we'll talk about here in just a moment, not only with research institutions, military academies, FFRDCs, that is federally funded research and development centers, and large businesses as well. So they're not just caged to universities if they don't need to be. Some basic information. It's as we mentioned before, STTR is a federal government program. You see the statute there. The DoD is one of 5 participating agencies. We'll move on to the third bullet here. The unique feature of the program is that you have a research institution in phase 1 and phase 2. So realize that when you go into that sole source justification in a phase 3 contract, that unlimited contract at the end, that requirement for a research institution does not carry forward. So that is only for phase 1 and phase 2. The biggest thing that we are here to do, and the way that this STTR program kind of fits into the larger innovation puzzle, if you will, is that this is pre-seed, pre-sales technology development. So we're really trying to bridge basic science and kind of the research side, grant side of the world, and the commercialized side of the world, right? The product development, the actual business side of things. As you can see here, we're very similar to SBIR in the fact that there's the 3-phase commercialization program, the discover and prototyping and transition, and the results in the sole source justification that we talked about just a few minutes ago. But some of the things that really make STTR special are listed here on the bottom part of the slide. So as we mentioned, it doesn't require any commercialized product to be available. We don't require any commercial traction up front, right? It can be as early stage as possible or as preferred. You just have to have a plan on how we're going to commercialize that moving forward. Again, it requires a qualifying research partner, and we'll touch on that qualifying part, what that means here in just a minute. A qualifying research partner to perform at least 30% of the work. That could be a university, it could be a nonprofit entrepreneurship center, FFRDCs we talked about. Additionally, this is an interesting point, a principal investigator can be primarily employed by the research entity, not only the small business. So they can be employed by either entity. So the classic example here is a tenured professor who has a high opportunity cost, isn't quite ready to separate from his day job, as it were, but still wants to realizes the opportunity to commercialize a certain technology. He can move through phase 1, phase 2, a strat-fi, and be in a 7-digit contract with the government, and then move over to the small business side if he so chose. So there's a lot of value in that particular caveat here. And ultimately, what we've done with the open topic, in contrast to the broad agency announcement and kind of caging ourselves to an R&D to R&D transition, we use a different type of contracting vehicle called a commercial solutions offering, a CSO, and that allows us to interact and get money from and get investment from the operational community just the same as we can get investment from the R&D community as well, which is a huge value proposition. So we'll talk more about this. So the research institution. So there's a lot of words on the slide here. We've underlined and bolded a couple of important parts, but the point here is that historically STTR has been all university engagement, right? It's all very formal universities. But what we've seen in our experience thus far, and in many of the studies that have been done, is that many times the universities may or may not be small business oriented. They may not be oriented to your particular technology space, right? They could be more biopharma type of thing, as opposed to a hard tech type of application, right? So part of the way that our process works is that one of the things that we highlight is simply that there's a lot more opportunity here than just necessarily the university that you're at, right? Ultimately, we do not match the research institution to the small business. That small business, when you come and put in your proposal, you come with a research partner in hand. Our put here is that you have agency, right? Who you partner with, whether it be another small business, whether it be large business, whether it be universities or any one of these other partners, that's a business decision that the small business has complete agency over. And we want to make sure that they are making the best decision for them, given the circumstances. So that's just one of the highlights that we make to say that there's a lot more opportunity than maybe a lot of folks realized. That's been written in policy this entire time. So that's good news. Additionally, so on the data rights thing, so intellectual property is a huge deal, especially for small businesses. And when you think about, the relationship here, when you have the government, the federal government, you have the small business, who can be maybe just a couple of folks, and then you have another large institutional partner in terms of the university or whoever else. In many cases, in most cases we've seen, if somebody has to give in terms of IP or rights or what have you, it's the small business, right? And so we want to make sure that we communicate the protections that are in place for small business to protect their IP. And to that end, the Small Business Administration has passed an update about this time last year to extend the commercial rights or the government use rights, to 20 years past the acceptance of the last SBIR or STTR contract, right? Previously, it was a 4-year, and they could ask for more, and it could re-up, if you will. With this, it's a straight 20-year data rights protection. There's a resource there if you want to learn more about the details there. But the point there is that we are small business focused, right? We are here to make sure that you have all the tools that you need to succeed, right? And that includes knowing what your rights are and knowing how you can best take advantage of the program. Okay. So we'll talk a little bit more tactically here in terms of what we're looking for from proposals. Those proposals are evaluated in 3 specific areas. Commercialization, right? It can be very early stage that we talked about, but you need to communicate clearly how you're going to commercialize that concept, that idea. That starts with understanding your market, both on the commercial side and on the defense side, as well as any external interest that you've gathered along the way, whether that be investors, whether that be other kind of development programs or what have you. We also look at the defense need, right? That's an important perspective as well. Again, understanding your market, understanding who would care, in simple terms, about the concepts. And I think Colonel Diller and the team here are great touch points and POCs for this program, for you as an audience specifically. But you can also capture that in other markets as well. So it doesn't have to be just Department of the Air Force, right? There's going to be people who are interested in eVTOL in other places, other federal government agencies, other services, etc. So we want to make sure, again, that we're diversifying that customer base and that stakeholder base along the way. And ultimately, there's also the technical and team criteria. Certainly the more mature, the better in terms of technical risk from that perspective. But ultimately, we want to make sure that with whatever technical risk that you're bringing to the table, you have the team and the plan to accomplish and move through that risk, mitigate it where appropriate, and ultimately be able to commercialize the product. All right. you know, there's lots of things that we can say in terms of results. I mean, we have shattered records left and right in terms of engagement for the earlier round this year. So in the 20.1 or the 20.A for STTR rounds, combined, we had almost 1,200 applications for phase one, which was pretty spectacular, right? That is an order of magnitude at least over what we've seen previously. And I think that's really attributable to this first bullet here, right? We are more together than we are separate. In terms of cost sharing, in terms of access to data and working together, we've been able to achieve some pretty spectacular results. You know, not only are we looking for your Air Force corollaries and stakeholders, but we really facilitate the opportunity for you to work with other services, other federal agencies like the FAA, for instance, as well. So they're all included in this. And then we mentioned, you know, part of working together is the distribution of knowledge, right? Not only the access to the small businesses, that is to say you all, not only to access to the government as well, but that results in distributed demand and ultimately distributed impact in terms of what your technologies can be used for and the good that we can bring to the larger community. Between 2018 and 2020, this year, we saw over $5 was invested for every $1 of SBIR and STTR funding. That's great not only for you as a small business, that's great for the government and the Air Force that we're not singularly paying for some of this research, right? And ultimately, and to be completely honest, it's great from a taxpayer perspective too, that we're leveraging our position to be more effective together. It's not only in you know, kind of the larger teamwork kind of mantra, but we've also done a lot of work in terms of our government processes. Timelines from contracting, as you can see there. We don't do a specific matching process, right? That's very much on the small business to achieve, but we want to make sure that we provide tools and training and opportunities, not only for the small businesses, but for the government folks as well, so that everyone has the warm and fuzzy about what we're doing, while we're doing it, and where they can go. With that, I believe we're towards the end here. And we're on the question slide. So just a final foot stomp on the pre-solicitation opening on the 25th of August. There's an asterisk there in that notes that there may be an opportunity to propose to STTR 20.B later this summer. There's also AFWERX challenges that some of which have just recently closed out, but there's a running list of those. And then you can always give us a ring or shoot us a note at SBIR or STTR at afwerx.af.mil. And we would love to touch base with you and your community and make sure everybody knows how they can take full advantage of the program. So with that, I will step back and we can jump into some questions.
Sure, thank you, Jared. A few questions we have here. First of all, what is the web address to apply for new open topics, and are there any issues for business partners that are not United States-based companies?
Hey, great question. So we use a DoD system for inputting proposals or for submitting proposals. DSIP is what we refer to it as the acronym. If you go to sbir.gov, you should be able to see that. That should lead directly to that proposal website. So you can type in SBIR DSIP, for instance, into Google, and that'll take you there as well. In terms of the second question there, international involvement. So there are regulations in terms of what the small business, or where the small business does its work principally, and who owns that small business. We can go through some of those if we'd like, but long story short is that we aim for U.S.-owned small businesses. And we can talk through some of those details if it's useful.
Sure, thanks, Jared. Maybe this is outside of your knowledge base, but Benjamin is asking, can you provide high-level comment explanation on the connection between STTR/Sbir public-private partnerships and the National Defense Authorization Act, FY 2018's pilot program on strengthening manufacturing in the defense industrial base?
Yeah, I'm not extremely familiar with what exactly we're asking, so I'd have to get a little clarification, to be honest.
Okay, yeah, no problem. Yeah, just a couple of questions on United States Air Force withdrawal from 20.2 Sbir solicitation, and just final clarity on when new open topics will be released, and are there any Agility Prime focused topics being released?
That's a great question. Actually, Zoe would probably be the best person for that. She leads a lot of our focus area opportunities, and I think Agility Prime could fit into that, but I'll let her speak a little bit more directly.
Yeah, so I guess kind of first of all, we don't have a ton of detail to give out, but the Air Force as a whole drew out of the 20.2 solicitation cycle, and it was basically due to just resources and all of the COVID stuff going on. So we released the 20.R for COVID technologies, and we put all of our resources directly into that to try to pull those technologies into the Air Force so we could continue to do our mission in this time. And so we just, you know, enable to fully be able to pull in those technologies and not, you know, diversify our funds too much. We kind of did that instead of 20.R. So as the Air Force, we pulled out and we're looking at 20.3, which I think you can see up on your screen right now for August 25th. Will be the next solicitation with the asterisk of maybe we can participate in a 20.B that will just be an out of cycle type of thing later this summer, as Jared said. If not, look for it coming out in August, and you can find information on the SBA.gov. As far as Agility Prime type of participation in Sbir, we are working with them. We have things called focus areas, and this relates to STTR as well as SBIR. And basically what we do is it's a big open topic, and anybody can submit their ideas that they think the Air Force needs. But in order to narrow that down a little bit and show, you know, you guys specific interest areas, we release what we call focus areas, and those are written up by different organizations within the Air Force and have a POC attached to them that you can talk to and get questions answered from specific to their focus area. And I believe we're working with Agility Prime to get one of those out. Whenever the solicitation goes out, it'll reference either a link or a website or a document somewhere, and you should be able to find those focus areas pretty easily. If not, after the solicitation pre-releases, you can always go to sbir@afwerx.af.mil and ask for that document and where to find it.
Super. Zoe, thanks for that. Yeah, the Sbir team, the AFWERX team, it has been truly heroic work that they've done in response to COVID over the last few months. And so that did, as you might imagine, kind of reshuffle some of the things that they were planning on doing. And to that end, that's where we're looking right now to answer the question. Are there some opportunities in the near term to do potentially an out-of-cycle STTR? We're going to investigate those if we find that there is, and we can focus some of that specifically to Agility Prime. Expect to see that information via the webpage or via some of the social media outlets. I think we also have email feed that goes out to provide the weekly updates for this particular topic. So thanks a lot to Jared and Zoe for providing that overview. Hopefully that gave you some good idea of the mechanics involved in creating and being able to look at those solicitations and creating some of the partnerships that might help both on the industry research and development, as well as bolstering some of our academic institutions, our research institutions, to develop that workforce that we're going to need as we're moving forward. So with that, thank you all for your time this week. We will be planning on meeting again this time next week to continue to explore these topics. And if there's additional news that we have on near term, we'll certainly get that out. But if nothing else, should give you a good background for those August releases and start thinking about how you could look at some of these universities and research organizations for that partnership. Thanks for your time and take care. Goodbye.